A digital signature is a mathematical scheme for verifying the authenticity of digital messages or documents. A valid digital signature gives a recipient a very strong reason to believe that the message was created by the known sender, this is what authentication means, and that the message was not altered in transit. Or, in simple words, if someone receives a message or downloads a file that is digitally signed, he knows that the message was really created by the sender and not spoofed by a hacker, and that the message was not tampered with or corrupted. But what is a digital signature? A digital signature of a file is the hash of that file encrypted with the private key of the user that signs. That's all. You can encrypt and sign a message or just sign a message without encrypting it. You do that when you want to share something in plain text or make a public post that everyone can read, but you want to include a signature to prove you are the original author and that your message is not altered in transit. If you don't encrypt the message, there is no confidentiality and it only proves integrity and authenticity of the message. In the real world, there are a lot of messages that are not confidential, like for example applications or software updates. They only need to be signed, not encrypted. Let's see the first type of a signature, which is called clear text signature. The document is not encrypted, only signed, and the signature is appended to the end of the document. This is very useful for text files or emails. This is the file I want to sign, and I'll rename it to secret.txt. Let's take this file and sign it. GnuPG clear sign and the name of the file. I'm signing with my private key, so I must unlock it. The command generated a clear text file that contains the signature at the end. Let's see its contents. secret.txt.asc. It's an ASCII file. This is the contents of the file and the signature. This is useful for pasting it into an email or posting it online. If you are not interested in generating a text file, you can use the -- sign option the same way, like this. And the resulting file is a binary one. This binary file is not encrypted, only signed. This command, GnuPG sign and the name of the file, compressed the file and then generates a new binary file called secret.txt.gpg. It contains both the file contents and the signature. So until this point, we have signed the file in two ways. We've generated an ASCII file and a binary file. And the last type of signature is called detached signature. The signature of the file will be in a separate file. Let's see the command GnuPG -detach -sig -output, the name of the file that contains the signature. Let's say secret.txt.sig, and the file I am signing, secret.txt. This is the signature. It's a binary file. Or, if you want to have the signature in ASCII format, you add the -a or --armor option like this. This was the command, and I'm adding -armor or -a. and the resulting file will be secret1.txt.asc. There is already a file called secret.txt.asc, and I do not want to overwrite it. That's why I'm using the name secret1. And this is the signature in ASCII format. Let's copy the files to the other Linux machine using SCP. The other user will verify the signatures. So SCP, the files, and I'll copy all signatures. The user, the IP address, and the path where the files will be copied in the home directory. And they are copied. These three files. Each file contains the content and the signature. Remember that the files were not encrypted, only signed. To verify a digital signature, you always need three things. The file to verify, it's here. The digital signature of the file, it's in the same file. And the public key of the one that signed. Let's see if we have the public key of the user that signed in the GPG keyring. It's not there. I must import the public key of this user. This is the key ID, and I'll import the key from the key server on this machine. In the last lecture, I've published both public keys on the key server, so this key is there. Copy, and GPG -- key server pgp.mit.edu -- receive and the key ID. The key was imported. Now, the user can verify the signature. Given a signed document, you can either check the signature or check the signature and recover the original document. To check the signature, use the -- verify option, like this, GPG -- verify, and the name of the file that contains both the file's contents and the signature. secret.txt.asc. And this is a good signature. We can assume that the file comes from the real user and was not changed in transit. To verify the signature of the other file, the binary one, I'll use the same command. And it's a good signature. The signature is good, but I've got this message, this warning. This key is not certified with a trusted signature. Is that okay? And the answer is that in these conditions, the warning is okay. A trusted signature is a signature from a key that you trust, either because you have personally verified that it belongs to the person to whom it claims to belong, or because it has been signed by a key that you trust, maybe through a series of intermediate keys. In our case, we've just imported the key from the key server without any other verification. This level of security is enough in most cases. Another option is to verify the signature and extract the document. We'll use the -- decrypt option like this, GPG -- decrypt or -d, it's the same, and the name of the file that contains the clear text contents and the signature, secret.txt.asc. And we see the content of the file and that the signature was good. The command printed out the content of the file at the terminal. If you want to create another file with that clear text content, you can use an output redirection like this, or the -- output option. Let's say secret.txt. This is the signature, and this is secret.txt, the initial file. The file I have signed. Let's see how to verify the detached signature. Remember that secret1.txt.asc is a detached signature. There's only the signature. To verify a detached signature, you execute GnuPG --verify, the name of the signature file, and the name of the file in clear text. This one. And we've got a good signature.